Jai Hind, Vande Mataram. This is Kunal Mehta from Make Me Scientific, and this is the last part of our video of the work, power, energy numericals, right? So I have covered up mostly all numericals in the past two videos. If you haven't seen them, please do that. Now in this video, I'm going to take up the numericals related to law of conservation of energy, as well as few complicated problems related to the same topic, right? Okay. So now, I will let you know about the different formulas while as we are going to solve the numericals, right? So what we are given over here is there is a ball whose mass is 0.2 kg and it is thrown vertically upwards. So when you throw something, suppose this is the ball, and when you throw something in the upward direction, you are always going to throw with some kind of force. Okay. Yeah, so you are going to throw with some kind of force. So the body is going to have some initial velocity. So we are already given that 20 meters per second, 20 meters per second is the velocity. Now, as the ball tries to go up, the Earth's gravity is going to pull it down. So the ball is going to de-accelerate in the upward direction. Its velocity is going to decrease. Now, we will take G as 10 meter per second square over here if it is not given to you. So, at some height above the ground, which is the maximum height reached, this ball is going to stop because since it is deaccelerating, finally its velocity is going to become zero, and that height above the ground is the maximum height achieved. Okay, the mass of the ball is also given to you. Now, what we are supposed to find out, calculate the maximum potential energy. See, here the potential energy is going to be the maximum because it is at maximum height, but the kinetic energy is going to be zero. So potential energy plus zero because the final velocity is zero. So this itself is the total energy. So the total energy at the top is equal to the potential energy, whereas exactly the place from where you are throwing, and we are going to consider that we are throwing it from the ground, over there it has got some kinetic energy, but it doesn't have any potential energy because mgh, h is zero. So the total energy is the entirely the kinetic energy. We are not going to consider any kind of air resistance during the motion. So that means the total energy at the top is equal to total energy at the bottom. So that means the total energy at the top, that is mgh, that is equal to the total energy at the bottom, that is half mv square. So this is half. Mass we are already given to us, that is 0.2. Everything is in SI unit, so we don't have to worry about that. And V is 20 meter per second, so 20 the whole square. Anyhow, in this problem, we are not going to use G, so you don't have to worry about its value. So this is 0, 0.1, so 0.1 times 400, and everything is in SI unit, so the answer is going to come in Joule. Okay, so like this. Question number 2, stone of mass 500 grams. So the mass of the ball is half kg. Please note we are supposed to take up all the values in SI unit, and again it is being thrown upwards with a velocity of 15 meter per second. Correct? We are supposed to find out the potential energy at the maximum height, kinetic energy on reaching the ground, and the total energy at its halfway point, right? So all answers are going to be the same. Let's discuss how. So you are throwing this particular ball in the upward direction, and the mass of the ball is half kg, right? So when you are throwing from the ground, it has maximum kinetic energy. You have used force in order to throw the ball, so it has maximum velocity because afterwards it is going to deaccelerate. So here the kinetic energy is k, that is half mv square, that is equal to half times mass is half again, and velocity is 15, so 15 15s are 225. So 225 divided by 4 is 56.25. Again the potential energy, this is in joule, potential energy is 0 because height above the ground over here is 0 at the bottom. Correct? So the total energy is the entire kinetic energy, that is 56.25 joules. Now when this ball starts going up, its velocity decreases and it becomes maximum at the top. So the potential energy where it is maximum, the velocity is 0. So over there, the kinetic energy half mv square is going to be 0. But as per the law of conservation of energy, the total energy everywhere remains the same. So total energy is equal to kinetic energy, which is 0, plus potential energy, which is equal to 56.25, which we already calculated from the bottom part here. So the total energy at the top is equal to the total energy at the bottom. So total energy at the bottom is kinetic, total energy at the top is potential energy. Now, in the same way, somewhere here, exactly in between or anywhere, the ball might be somewhere up or somewhere down, the total energy always remains the same. So it is still 56.25 joules as per the law of conservation of energy. But this is only true if we neglect the air resistance, which we are going to do in these kind of problems. Okay, fine. Now, the metal ball of mass 2 kilogram is freely falling. Now, when in case of the free fall, when you are throwing something up, the velocity is something, and at maximum height, velocity becomes 0. Here, when you leave something, it's a case of free fall in the downward direction, the initial velocity is always 0. In case of free fall, initial velocity is 0. So the kinetic energy at the top is going to be 0. Okay, let me call this point as point A. Now, the height above the ground of point A is given to you as 5 meter. So we can very well find out the potential energy at the top, that is mgh, and m value is already given to G is 10. So this is 100 joules, which means the total energy is kinetic plus potential, that is also 100 joules. Correct. So the answer to the first part, the potential energy possessed by the body is equal to 100 joules. That is the answer. The kinetic energy of the ball just when it hits the ground. So as the ball comes down, its height above the ground decreases. So the potential energy decreases, its kinetic energy increases because the total energy has to remain the same. So when the ball is just about to touch the ground, the potential energy is 0 because height above the ground is 0. So the kinetic energy has to be 100. Then and only then the total energy will be 100 joules, because the total energy at the top should be equal to total energy at the bottom as per law of conservation of energy. The third part, what happens to the mechanical energy when the ball hits the ground and comes to rest? So right now the ball is just above the ground, but when it collides with the ground, it is going to produce the sound, as well as due to the friction between the ground as well as the ball, there is some heat energy that is going to be liberated. Of course, you can't account for that energy, you can't use that energy, you won't be able to even find out that energy. That's very difficult. So we make an assumption that when it collides, the entire energy dissipates in form of sound and the heat energy. Now, in this diagram, what we are given, in this diagram, we are given that a ski jumper of weight 60 kgf, that means the mass of that person is 60 kilogram, stands at point A. So the person is standing somewhere over here, and then he moves from A, takes off the jump from B. So that means he is going to slide down, which means the potential energy is going to decrease because the height above the ground is decreasing. After some time, the skier may be somewhere over here. So height above the ground is definitely less than 75 meters. In the same way, when he comes here, then after he is going to jump in this way. Correct. Now what we are going to find out, calculate the change in potential energy between point A and point B. So here, this is point A, which is 75. This is point A, and then this is point B. So this is 75 meters, and this is 15 meters, correct? So potential energy at A minus potential energy at B, that is mgh1, or HA I should write down, minus mghb, where h is the height above the ground, mg common, HA minus HB, So which is equal to mass is 60 kilogram. This is the weight, please understand, 60 kgf, right? G value we are going to take 10. Yeah, if it is not given in the question, we'll take 10. Times the difference in height is 75 minus 50. So this will be 60. So that means that will be 6 6 are 36, 36 000 joules. That will be the answer to the first part, A part. Now, it is being said that if 75% of the energy in A, that is 75% of this 36,000 joules becomes kinetic energy at B. So kinetic energy at B, that is equal to 75%. So 0.75 times 36,000. This is the kinetic energy. Now that itself is the half times mass, and the mass is 60 times V square. So 0 0 getting cancelled, 6 1s are 600s are. So this is 75 times 6 times 2, that is equal to V square. Correct? So 75, so I should be writing V square, that is equal to 75 times 2 into 6. So this is 75 to the 150, 150 times 6. So this is equal to 6 5s are 30, 0, 3 carries, 9 and 00. So like this, V square. So V is equal to under root of 900 and everything is in SI unit. So answer would be 30 meters per second. That is the answer to the B part. Let's move on to the next problem, that is hydroelectric power station. So something like this. This is a check dam and there is a lot of water available on this side of the dam, right? And then the water flows from the top, right? And then it falls down, and here at the bottom we would be having the turbine which is connected with the generator, and then it is going to produce electrical energy. But if you look carefully, what is happening, some mass of water, let's say m kg of water, is falling on this turbine, correct? In 1 second, please understand, in 1 second m kg of water is falling. So m kg of water has potential energy mgh because it is at some height above the ground, and this height above the ground is h. This is the ground, like this. So mgh is the energy which is carried by m kg of water. Now since this is falling on the generator, generator is going to produce electrical energy, which is going to be the output energy, whereas this is the input energy, correct? Now efficiency is equal to output energy upon input energy times 100%, correct? So that is what is happening over here. This is output power, that means 10 raised to 6 watt or 1 megawatt is produced. That means 10 raised to 6 joules is produced in 1 second. So that is the output energy, right? And efficiency is 40%. So 40% is 0.4. If you are writing 0.4 over here, no need to write down 100% over here. So output energy, right? Output energy divided by input energy. The input energy itself is due to the m kg water, that is mgh, and output is 10 raised to 6 joule. So now if you solve this, 0.4 times mass we don't know, times g is 10, times h above the ground is 50 meters, that is equal to 10 raised to 6 joules. Now see, everything is happening in 1 second. The m kg water which we have assumed is falling on the turbine in 1 second. You understand that it's a very big stone made up of water of mass m kg. That stone is falling on the generator, correct, in 1 second. Another stone of similar mass of water is falling again in 1 second, like that, right? So here 0.4 times m we need to find out. This is 500 is equal to 10 raised to 6. So this will be m times 200, that is equal to 10 raised to 6. That is 1 2 3 4 5 6. 2 zeros getting cancelled, and everything is in SI unit. So mass is 5000 kg. That is the answer to the problem. Moving ahead, Simple pendulum has a velocity at its mean position. So if you have a simple pendulum, it will oscillate like this, and at the extreme position it will stop, so its kinetic energy is going to be zero, but its potential energy would be maximum because it will be at maximum height above the ground. So when it again comes down here, the potential energy becomes zero, but the kinetic energy is going to be the maximum, right? So it will have maximum speed or the maximum velocity. Now we are given that the maximum velocity at the mean position is 5 meter per second. So we can very well find the kinetic energy. At what level it will rise if it loses 60% of its energy in overcoming the friction. So if we calculate its kinetic energy, that is half times the mass is m times v square, that is 5 square. I have seen many students who are struggling that, sir, we are not given the mass. Please understand, if something is not given in the question, that means it is not required, right? Now this is the maximum kinetic energy at the bottom. Now ideally that should be maximum potential energy at the top, provided there is no air resistance. But here, as the bob starts moving upwards, it faces the air resistance. There is a collision of bob with the air particles, due to which some amount of energy is lost in form of heat. So 60% is lost in overcoming the heat energy, in overcoming the air resistance. So what is left at the maximum height? 40%. So ideally you understand it like this: 60% is lost. So whatever energy is there at the bottom, its 40% energy is used to convert it into the potential energy, right? So this is times 40%, that is 40 by 100. That itself is equal to the potential energy at the maximum height. Ideally it should be 100%, but it is losing energy. So m getting cancelled from both sides. As I told you, if it is not given, it's not required. So half times 25 times 40 by 100, that is equal to g, we are going to take 10, and height we are supposed to find out. So 0 0 getting cancelled. Then this is 25 4s 100 divided by 20 times 10, that is equal to h. So this is 0.5 meter. That is the answer to the problem. Now had it been, okay, let me take this question one step further. Half times mv square, that is equal to mgh. Let us assume no loss in the kinetic energy, which is going to be converted into potential energy. So simply v square, that is 5 squared, so 25 by 2, that is equal to 10 times h. So this will go down, so height will be 25 by 20. So this height will be 2.5 divided by 2, so that is 1.125 meters. Ideally it should go to a maximum height of 1.125 meters if there had been no air resistance taken into the account. Let's move ahead. Now these are some challenging problems for 10th standard students. So if you are just opting for boards, you may just skip this part, but ideally I would recommend that you just see this once. Okay. So we are been given the mass of the ball as 50 grams. So 50 by 1000 is the mass in kg. Now it is being vertically thrown up with a velocity of 20 meter per second. The initial kinetic energy needs to be found out. V is 20 meter per second. So initial kinetic energy is half times mass times 20 square. So this is half times 50 into 20 into 20 divided by 1000. So these three zeros gets cancelled. So the answer is 10 joule. Maximum height reached if air resistance is neglected. So that means the total energy at the bottom, which is the entire kinetic energy, as I said before, total kinetic energy is 10 joules. That itself is going to be converted into mgh. Alright, the total energy at the bottom, which is entirely kinetic, is going to be the total energy at the top, which is entirely potential. So this is 10, that is equal to 50 by 1000. into 10, G is 10, height above the ground is H. So these two zeros getting cancelled, 5 ones are, 5 twos are. So height above the ground is 20 meters. This is in ideal conditions if we do not consider the friction. But now 40% is lost. Please understand, 40% is lost. So the remaining energy is 60%. So the potential energy, that is mgh, is only going to be 60% of the total energy at the bottom, which is the kinetic energy, that is 10 joules. Right? So again, basically this is 50 by 1000 into 10 times height above the ground will not be 20 meters. You can directly find 60% of 20 meters. So that is 12. That will be the answer. But still, let us calculate it by this way. These 2 0 getting cancelled, 1 0 getting cancelled, 5 ones are, 5 twos are. So the height above the ground is 12 meters. This will be the answer to the problem. A ball of mass 20 grams is falling from a height 10 meters, then strikes the ground, rebounds, then goes like this. So we will consider a ball from location A. Now it is at some height above the ground, like this. Okay, that is 10 meters. But now when it hits the ground, due to the friction and the collision between the ball and the as well as the ground, some amount of energy will be lost in form of heat and sound. So the maximum energy, the total energy at the top, which is only potential, that is m, we have to convert that into kg, g is 10 times h. So basically this is 2 joules, and since it is being left free fall, so zero kinetic energy, so the total energy is equal to 2 joules. This is kinetic energy, which is 0, and this is the potential energy, right? Now when the ball strikes the ground, here it should have total 2 joules of energy, but now due to collision it will lose some amount of energy. Had it been no loss in the energy, the ball would rebound back to the same height, because the total kinetic energy at the bottom will be again converted into total potential energy. So the ball must rebound back to the same height, but it will not happen because it is losing some amount of energy. After rebounding, it goes to say 8 meters above the top. Which means if I find the potential energy over here, that is mgh, that is 20 by 1000 into 10 into 8, right? So these 2 zeros, ones are, 5s are, 5 ones are, 5 ones are 5, then 5 6 are 30. So that is 1.6 joules. That is the total energy, or that is the potential energy. Now just imagine like this. The ball at the top was having 2 joules of total energy. It struck the ground at the bottom. Had it been no loss in the energy, it would, that means the kinetic energy would be 2 joules at the bottom. Now the same kinetic energy would be getting converted into 2 joules of potential energy. Again 2 joules of kinetic energy, again potential to kinetic, kinetic to potential must happen. But what is happening practically over here is it has 2 joules of energy. Now it, before striking the ground, just before striking the ground, it had 2 joules of kinetic energy. Now when it, since there was a collision, some amount of energy was lost. So now some new kinetic energy, let me call that as k dash, which is less than 2 joules. Now this entire kinetic energy would be getting converted into the potential energy, and that potential energy is 1.6 joules. So that means the kinetic energy at the bottom, k dash, is also 1.6 joules. Correct? Like this. So the loss in the kinetic energy of the ball, that is 2 and 1.6. Earlier it was 2 joule, now it is 1.6, so 0.4 joules is the loss. What happens to the loss in the kinetic energy in part 2? It is getting converted into sound and heat. I hope this question is well understood. 2 joules at the top is 2 joules at the bottom before collision. After collision, it is 1.6. Now, same 1.6 is getting converted into same 1.6 at the top potential, because we are not considering the air resistance, like this. Last problem. The simple pendulum has mass of 500 grams. So basically mass is half kilogram. Now it reaches a height of 5 centimeters above the ground at its maximum position. So height above the ground is 5 centimeters. G we are going to take as 10. So here the maximum potential energy, that is equal to mgh, mass is half kg, g is 10 meter per second square, height above the ground is 5 centimeters, so 5 by 100 meters, correct? So this will be 0 0 getting cancelled, 5 1s are 5 2s are 1 by 4, so that is 0.25. Everything is in SI unit, kg meter per second square is joule. So maximum potential energy we found out to be 0.25 joules, correct? And here the kinetic energy is going to be 0 because the bob will be at rest at maximum height. So the total energy is equal to kinetic plus potential. So this is 0.25 joules plus 0 joules. So answer is 0.25 joule. That is the answer to the first part. Velocity of the bob at its mean position, and we haven't taken air resistance into our account. So with the assumption that we are making is no air resistance or no loss of energy, you can consider. So the total energy at the top will be equal to the total energy at the bottom point. So here the total energy is potential energy plus kinetic energy, but the potential energy is going to be 0 because this bob at the mean position is touching the ground almost. So the kinetic energy is half mv square, and half mv square is equal to mgh or 0.25 joules. Now very carefully plug in the values. I have student making the mistake of not converting the CGS units into SI unit. So half times mass of the bob was half kg times v square is equal to 0.25. So this is v square by 4. V square is equal to 0.25 into 4 is 1. So v is equal to under root of 1. So v is equal to 1 meter per second. That is the answer to the problem. So I hope you might have understood this problem. Please like my video. If you have any doubts, do comment in the comment section. Thank you for watching the video.